Hello, today we're going to talk about Isaac Sim and utilizing it in my latest project, which is a poop scooping robot. Very, very exciting about a poop scooping robot. But the idea is I'm going to build a robot that will run around my backyard and pick up the poop. It's that simple. I have dogs, they poop. I don't want to go back there and cleaning up every night, every day, but I do want my backyard to be nice and clean, and I take my dog for a walk, and sometimes he goes before, and it's kind of too much information. But I've already have a Jetbot, as you've seen in previous videos, and what I'm going to do is utilize the Jetbot to do a bit of machine learning inside of my home. But first, before I do the machine learning inside of my home, I want to simulate the environment. So I want to take that Jetbot, I want to run it around some indoor environments, both using AWS RoboMaker in simulation and Isaac Sim. So we're going to go over what Isaac Sim is today, and eventually I want to get to my next robot, which is this. As you can see, I want to give credit to the author here of this design. You can find this on Hackster, I believe, or something like that. I'll put that in the link. And what this robot does, it has some you can see the motors back there, and it's basically a set of wheels right now, and some treads. So I'm designing an enclosure on top of this. It comes with a kind of general enclosure like this. But what I'm going to do is design a enclosure that will house my NVIDIA Xavier and a LiDAR as well, and a depth camera and an arm for the poop scooping. And the back is going to have a little bit of a holding pin for the remnants that are picked up. So this is a long-term project, but I'm going to reutilize tools that I've already built in the past, which are a lot of the machine learning, computer vision based products, as well as SLAM, simultaneous location and mapping, that I've already done in the past, and the ability to give me updates using the cloud and various tooling around that. It's going to utilize ROS 2 as I typically use in most of my projects, and just the tools that are already available within Isaac Sim, ROS 2, and others. So in the past I've done these things with Gazebo. Gazebo has worked very well. Now I'm going to utilize Isaac Sim, now that it's gotten more mature, to do a similar thing. Okay, that being said, today we're going to talk about Isaac Sim. Just general what you need to do, what you need to have to make Isaac Sim work. We're going to take a look at Isaac Sim at its very, very core base, what it does, and then some of the other tools that are also available from NVIDIA as well. And in the next one, we will go into machine learning using the Jetbot, and from there we're going to progress on and on and on using ROS. As well, we're going to take our own URDF file, bring it into Isaac Sim, use it there as well. And at some point, we're going to use Fusion 360 to build the actual finished product after we're done using Isaac Sim. Well, what is Isaac Sim? The idea is that there are a lot of tutorials out there about what it is, but I'm going to give you the very, very quick and dirty baseline of what I think it does for me. And that is, it's allowing us to create multiple simulations using 3D high resolution, real world physics engine based robotic simulation. So what I'm going to be able to do is take my own robot or example robots, bring it into this high resolution world, and train essentially train my robot by utilizing the components that I already have, my machine learning models, seeing how they perform against real world conditions, and and visualizing that data. So we're going to create some data, we're going to get some synthetic data, we're going to utilize all those things, so my robot doesn't end up going around my house and picking up, say, my dog's tail or running into the pool and all those kind of things. So enough talk. Let's get to the action. Let's look at this robot, this Isaac Sim, excuse me. First thing you need is we need to look at the requirements. So number one, Here I've listed the requirements for Isaac Sim. Requirement number one is Ubuntu processor OS, a i9, or I would say an i9 processor. I tried this with an i7, did not really work for me, and 8 to 16 cores, definitely 64 gigabytes, I believe, of RAM, and then storage somewhere in this realm. One good thing to know, one thing to be aware of, is you can utilize the cloud to build up your instance of Isaac Sim. I don't know about Azure very well because I haven't tried in Azure, but I definitely tried this in AWS, and I was able to stand up Isaac Sim running in AWS. So what we're going to see today is it not running on AWS. You're going to see it running on my local machine, which I have a well, let's show my specs real quick. I think I still have them up here somewhere. So I have here running this version driver, NVIDIA, CUDA is 11.2, and I'm running RTX 3080, and requisite amount of memory. Here we go. Okay, those are my specs. Just so you know, that's pretty much bare minimum what you're going to need. I did try to run this before with a little less than on a laptop, and no joy there. So those are the requirements. There are driver requirements, and if you're going to build this up in a container, NVIDIA has their own container requirements, so those are some things you should know. And if you're going to try to build this and run this in the cloud, again, at least I can't speak for Azure. For Amazon, there's an instance that's already built that has the majority of the things you need already running and easy to spin up, and you pay by utilization, not it's just not running long term. For instance, I built and bought a box, probably thousands of dollars worth of equipment within that box to make this thing run. But you can also mimic the same thing and pay cents for usage. Anyway, enough of my plug of Amazon. All right. That being said, let's move on. Let's get into it. So you download the Omni launcher. Omni launcher it's basically a shell that contains all the tools that you would need to use for to run Isaac Sim and other things. So if you go to the Exchange here, you'll see there's various applications that are available and connectors. So if I want to connect my Maya instance directly to the system, I can do that. Here's a connector, sample connector right there, and so you can make many different connections. And as you develop and design different applications, robots per se, let's stick with the robots, you will see those designs in real time, and you're able to run that against your simulations in real time. Some of these I have not messed with simply because I'm not a graphic designer or 3D designer in that way. I do a little bit of it, but not enough to be dangerous. So I'm going to stay away from things that I don't know, and only going to talk to you about Isaac Sim. So in order to run Isaac Sim, you should have what we call a nucleus service running, and a nucleus service basically brings together all of your potential components into a local or networkable set of folders. So I can share the work that I'm doing, my progress, among many users. And here is a specific to Isaac Sim folder that can house my environments, my materials, my robots, samples that can be accessed by many people, which is the beauty of this, and for use. The other thing that I'm running in the background here is a cache. So these are my cache settings in the background. Isaac Sim has also provided a web-based log and information about my running applications. These are the things that are running, and this is very helpful because sometimes you start the Omni launcher and all of these things aren't running as they need to be, and you need to actually go here and make sure that that's what's happening. The other thing that I had to do to get started here is upload assets from somewhere. In this case, I uploaded the sample assets to get going, and it has a list of robots and environments and all of those things and samples. But as time goes on, this is where you would also go ahead and upload your own robots or your own materials, etc. So the things that you really need to know offhand before you get started. Okay. That being said, let's launch Isaac Sim. Okay, so I go to Launcher, I click on Launch, and then another menu pops up and allows you to open it in the headless mode or using the IDE. So I'm going to use the IDE. To start with, it's a bit slow to get loading, but once it's loaded the first time, it's pretty awesome, I think. So today we're just going to focus on the basics of this IDE, which is very similar to, in my mind, to Unity or Blender or any of the other ones that you're used to. There's a console. There's some kind of file storage area that gives you your components that are within your files. It looks a lot like Unity, just to be frank. And then a properties window and a bit of information, more detailed information, depending on what you click on. Both of these windows change. And then here you can see this is the camera perspective, and then we're going to go over what these things are as the weeks go on here. And this is probably like a 6-part, 7-part series. I have not written it all down yet to figure out how big it is, but we'll just assume it's going to be at least that big, because we have the Jetbot we're going to work on for 2 or 3 sessions, and then from there our own file that we're going to work on beyond that, and then we're going to gather some data and see what happens after. Probably about a 7-part series. Okay, so today we're just going to look at the example, and I'm going to start out with a basic example very similar to the Arduino IDE when we start out with let's control something basic. So I'm going to create a Jetbot keyboard, and it's going to ask me, hey, do I want to load a Jetbot already? Okay, so Jetbot, again, just like similar to our Jetbot here. So here's a Jetbot. Oh, there you go. And it's got a LiDAR on top, camera on the front. These are available, I believe, around $100 some odd bucks. Not with a Nano included. Here's a Jetson Nano. This is a 4 gigabyte Nano. They also come in a 2 gigabyte form for 69 bucks. I also have Xavier's and bigger, more complicated beasts, but we're going to use this one for now. So anyway, this is the Jetson Nano. Sorry, within running on a Jetbot. There's a camera up front there, just like you saw before. This one, I don't believe, has LiDAR, but we could upload the spec for the one I just showed you, your RDF file, and use that one instead. This one does everything I need for now. It's got the camera just like I need. If you hit play here, the physics do happen. So you see the Jetbot has moved down to the ground where it belongs, and now I can drive it. I'll back up here so you can see I can drive it back and forth, around and around, using the keys there. It drives almost identical to how I would expect. The physics on the surface are pretty dead on. Friction seems to be dead on. The way this drives, if you've seen me drive the Jetbot, in reality this looks very similar. So how does that happen? And that's the first thing we're going to talk about. We're not going to get into the synthetic data or computer vision, machine vision kind of thing right now, but just want to go over the IDE as we see it right here. And here's the IDE. Here's the Jetbot. So here I can click on there. There's the left wheel we're looking at. There's the right wheel, and it's showing the X, Y, and Z coordinates of that particular wheel. The material of the wheel, you can change the materials here if I wanted to change the various materials of each part. And then I can look at the physics of all these things. Here's the physics of the seam. I can also look at the physics of the wheel itself, and whether it's a rolling wheel or those kind of things. I can look at those physics. So if I look here, here is the left wheel joint and the right wheel joint, and you can see that physics revolute is selected. So this is going to spin on its axis, and then shows the current positions and target positions and all those kind of things. The other thing to notice here is that if I look at render settings, it's very important that when I'm doing this machine learning kind of project, that I want to be sure that the lighting conditions are reflective of the lighting conditions that I'm going to have in the real world. They're not going to be ideal with dome lighting over the top. It's going to be the sun is going to be over here, over there, over there, and they're going to be shadows and shades. And I want the robot to be able to react in those same conditions. So for the Jetbot, since it's not big and beefy, it's not going to be outside. I'm going to use the Jetbot primarily inside, just like I've done with the Teledrone inside, and I want the environment to be similar to a real world environment. So I've, using photogrammetry, have mapped my entire garage, and I'm going to make the Jetbot walk through my entire garage, which if I showed you around here, you can see from up there the kind of cluster I have going on behind me with the drones on my workbench. There's quite a bit in here to navigate around, and that's the idea, is I want it to be able to move around my children, my toddler, not hit anything, not hurt anybody, because again, this is going to have, it's going to be about the size of this thing, maybe even a little bit bigger than this. This is about a foot and a quarter box, let's say, just a rough spec here. But this is not the final product. The final product is going to be metal, and about 2 feet by 2 feet by 3 feet high. So this is going to be much beefier, and I definitely don't want my children running into this robot, or my dogs running into this robot and having the robot have an adverse effect on my kids or the robot. There's a pool behind my house that is the reason why I'm actually needing the robot, is because I want to invite people over, and I don't want poop sitting out on my pool deck that I didn't see. So the robot's going to roll around looking for it intentionally, and I might actually have it even coordinate with one of my drones to actually figure out where the poop is. Or it might even, I have cameras behind my house, maybe it can watch my dog poop and then go ahead and tell me, oh, the poop's happened, and send out the robot automatically. So those are things that in the world of IoT are going to become commonplace. And just to start with today, like I said, step one, get the robot working in simulation, moving around the way we want it to work. So we have the simulation, here it is. And step two is going to be use machine learning to figure out its environment, how to navigate around a track, and then how to navigate around my house, and then eventually how to navigate around the back of my house. So this is just a quick video, get started video to introduce Isaac Sim. And in the next one, we're going to look at computer vision using the Jetbot in simulation. And the next one after that, we're going to introduce, I believe, Ross and Ross Bridge and how that works with Jetbot. Okay, thanks, and we'll see you in the next one.